Welcome to a 2-sample t-test example. So in this example, a study was run to determine if CSU students average more hours of work a week than UC students. A random sample of 50 CSU students averaged 18.2 hours of work a week with a standard deviation of 8.3 hours. A random sample of 40 UC students averaged 12.5 hours of work a week with a standard deviation of 4.5 hours. Can we conclude at the 5% significance level that CSU students average more hours of work a week than UC students? So just a side note, this is completely made up data. I don't know what the actual population averages are for either of these. So going through here, sort of our research question, we are trying to determine if CSU students average more hours of work a week than UC students. So this is a yes/no question. So this means we are doing a test. We are talking about the average. So we know we are dealing with the mean. And then we have CSU students and we have UC students, and we're trying to compare them. So this is a 2-sample t-test, just like I said in the title of the video. We have a random sample of CSU students. They had an average of 18.2 with a standard deviation of 8.3 hours. So that all is from our random sample of CSU students. Then we also have a random sample of 40 UC students with an average of 12.5 and a standard deviation of 4.5. Other significant information we need as we are looking at the 5% significance level. So the first thing we want to do is we are trying to understand the problem. We figured out that we are doing a 2-sample test about the mean. And again, we're doing a t-distribution because we only have the sample standard deviations. From here, we should record all of our sample information. So we have two populations. So we'll make population 1 be our CSU students. For population 1, we took a random sample. Which is drawn from the entire population. And we have our sample size was 50. So N1 equals 50. The sample average was 18.2. So X1 bar is 18.2. And the sample standard deviation was 8.3. So this is sample standard deviation, that's S1 is 8.3. Then what we have is for our second sample, we are dealing with population 2. So population 2 is UC students. And we have that sample was 40 students. Oh, we had that it's random sample drawn from the entire population. We have the sample size N2 was 40. We have the mean was 12.5. So X2 bar is 12.5. And the sample standard deviation S2 was 4.5. And then the other information we had is that it's a 5% significance level. So this is all of the information pulled from the problem, labeled with symbols. The next thing we want to do is write our hypotheses. So we're trying to see if the CSU students averaged more hours of work a week. So that'll be our alternative hypothesis. So CSU students average more hours of work a week than UC students. And the null hypothesis would be that CSU students average the same hours of work a week as UC students. In terms of symbols, our null hypothesis, we are claiming that mu1 equals mu2, or equivalently, mu1 minus mu2 equals 0. So we get that essentially by subtracting mu2 from both sides. And then our alternative hypothesis is that mu1 is greater than mu2, or subtracting mu2 from both sides, we get mu1 minus mu2 is greater than 0. The next thing we need to do is justify that we can run our test. All right, so we need to justify. This is our justification. So we need a good sampling technique for both samples, and then we need our normality condition. So for a good sampling technique, for both samples, so we have both samples were random. And both were drawn from the entire population. And then we need to check our normality condition. So for our normality condition, both samples were large enough. Both samples were 30 or larger. So this was our option 2 for our justification. Both samples were 30 or larger. Again, that is the requirement for this x1 bar minus x2 bar distribution. So
you find every chord there is.
We can run the test.
You find every chord there is.
Because there was a good sampling technique for both samples. And the normality conditions. For the x1 bar minus x2 bar distribution were met. From here, I'm going to let you just go straight to using Desmos to finish these calculations. So you need to have all your symbols identified in order to use this Desmos program. You also should know your hypotheses, and then you need to check that we are allowed to run the test. But after that, you are welcome to just let Desmos do the work for you. So from here, we will use, so for steps 4 and 5, our usual sort of process for continuing with our hypothesis test, we will use Desmos to do the work for us. So I had a link up at the top to take us to the Desmos program. So if we follow this link, we are now going to plug in all that information that we had. So our sample size for sample 1 was 50. The sample mean was 18.2, if I remember correctly. And I believe the sample standard deviation was 8.3. For sample 2, the sample size was 40. Okay. Okay, so we had our sample 2, we had a sample size of 40. The mean was 12.5, oops, 12.5. And the standard deviation was 4.5. So here's the picture we're looking at. Our t-test calculations, you can see kind of all the calculations would be done in the background. So our estimate for the standard error would wind up being 1.37. The relevant t-score would be about 4.15. The degrees of freedom calculation is horrific. When we were dealing with just one population and one sample, we just did n-1. You can see that the degrees of freedom calculation when we are dealing with 2 populations and 2 samples is much more complicated. For this problem, our alternative hypothesis was that mu1 minus mu2 was greater than 0. So we are looking at the right area. So the alternative hypothesis we should look at, or sorry, the p-value we should look at is this 0.0000415. So essentially our p-value is basically 0. So I'm just going to take a picture of the screen and add it to our notes. All right, so I have our standard error, our t-score, our degrees of freedom, and the p-value here. Again, our alternative hypothesis was mu1 minus mu2 was greater than 0. So we use the right area. And so this is our p-value here. So from here, that p-value is definitely under 5%. So this is way under 5%. So our difference in samples is extremely surprising. So the difference in sample means that we got would be extremely surprising. If the means were equal. So if the means were equal. So we move on to what would usually be our step 6, our conclusion. When we have a surprising result, this makes us doubt our null hypothesis and conclude the alternative. So we can conclude at the 5% significance level that CSU students average more hours of work a week than UC students. So it's the same concept as what we've done before in terms of running a hypothesis test. Same rules apply, but now we are letting Desmos do the calculations for us.